All right, we are looking at sample spaces and the fundamental counting principle, and this is 9.2 and 9.3 from your textbook. And our learning targets are, I can find sample spaces and probabilities and use the fundamental counting principle to determine possible outcomes. Okay, some new vocab here. Sample space. Okay, this is the set of all of the possible outcomes in a probability experiment. Okay, and we are also going to be looking at tree diagrams, which I will show you. It's a way to find all of the sample spaces, but I'll show you what those look like when we get there. Okay, so a vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or sugar cone and either hot fudge or caramel topping. Find the sample space for all the possible orders of 1 scoop of ice cream in a cone with 1 topping. Okay, so we made this table that shows all of the possible outcomes. So you can either get vanilla ice cream or chocolate ice cream. Then within there, you can choose if you want a waffle cone or a sugar cone. And then you can choose your topping of a hot fudge or caramel for each of those. Okay? And the same thing for chocolate. You choose your type of cone and then which topping you would like. And that's how you find the total sample space, the total number of outcomes for this situation. All right, so we have an example here. The animal shelter has both male and female Labradors in yellow, brown, or black. Find the sample space for all possible Labradors available at the shelter. So first you would pick, you could have a male that is yellow. Okay. You could have male that is brown. You could have male that is black. Okay, so those are all the Labradors that are male. And then the same thing for female. You could have a female yellow lab. You could have a female brown lab. Or you could have a female black lab. Okay, so this tells you the sample space for this, all of the Labradors that are available at the shelter. All right, so now we are looking at making tree diagrams to figure out the sample space. So a car comes in silver, red, or purple as a convertible or a hardtop. So the way that this works is we start with the color options for the car. We have silver, we have red, and we have purple. Okay. Then off of each of those, you can pick if you want a convertible or a hardtop. So silver, you can pick convertible or hardtop. For the red, you could pick convertible or hardtop. And for purple, you could pick convertible or a hardtop. Okay, so this tells us all of the sample space for this car. Okay. Next one, at the deli, I can choose from the salad bar, wing bar, or soup bar. I can get a bun or breadstick. And for dessert, I can select a pudding or slice of pie. What are the combinations of meal options? So we are going to make a tree diagram for this. First, starting with, well, I can pick a salad bar. I can pick the wing bar, or I can pick the soup bar. Next, I choose if I want a bun or breadstick. So from salad, if I chose the salad bar, then I can pick bun or breadstick. Okay, let's say I chose the wing bar. Well, I could pick bun, I'm going to abbreviate to breadstick to bread. And if I pick the soup bar, I could pick bun or breadstick. Okay. Now let's say I chose salad and bun. Then I could choose either, I'm just going to zoom out a little here. I could choose pudding or pie. Let's say I chose salad and a breadstick. I could choose pudding or pie. Again, I'm just abbreviating them. Let's say I chose wing and a bun. Then I could choose for dessert pudding and pie. And for bread, or if I chose wing bar, breadstick, I could pick pudding or pie. If I chose soup and a bun, I could pick pudding or pie. And if I chose soup and breadstick, I could pick pudding and pie. Okay, so this is telling us all of the possible outcomes. So now let's go through and count up the total number of outcomes. Salad bun pudding, that's 1. Salad bun pie, that would be 2. Salad breadstick pudding would be 3. Salad breadstick pie would be 4. Wing bar bun pudding is 5. So if you get it, we're kind of just counting all of these ones here at the end to figure out that there are 12 meal options at this restaurant. Okay? So that is what a tree diagram finds. It finds all of the possible outcomes. So now we're going to find probability of these events. So Marcos tosses 3 coins. If all 3 coins show up heads, Marcos wins. Otherwise, Kara wins. Find the sample space, then find the probability that Marcos wins. So let's see. We toss the first coin, and we could get, so first we have to make our sample space, and we're going to do a tree diagram. Okay? So toss the first coin, we get tails or heads. Those are the 2 options. Now, let's say we got tails on the first coin. We flip the second coin. We could get tails or heads. Let's say on that first coin we flipped heads. Then we could get tails or heads on the second coin. Now, we're on to our third coin. First flip, we got tails. Second flip tails, we could get tails or heads on the third coin. Same thing if we got tails, then heads, then we could get tails or heads on the third coin. If we flipped heads, then tails, we could get tails or heads on the third coin. If we got heads, heads, we could get tails or heads on the third coin. Okay, so that's our sample space. There's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay, that's just something to note for the next part here. Now let's go through. If all 3 coins show up heads, Marcos wins. So let's see. We have to go through and find heads, heads, heads. That's only one of our combinations. Okay, so Marcos has a 1 out of how many total outcomes? Well, 8 total outcomes, so he has a 1 out of 8 chance of winning. Okay, study tip to note, fair game. A fair game is one in which each player has an equal chance of winning. This game is a fair game, so just something to note. All right, next thing, fundamental counting principle. This is if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible outcomes. So let's see, what does that mean? Okay, so our example here, find the total number of outcomes when a coin is tossed and a number cube is rolled. So let's first look at the coin. Okay, this would be like event M. We have to find out how many possible outcomes are there for flipping a coin. Well, there's heads or there's tails. So there's 2 outcomes. Okay. Now, next thing, we are rolling a number cube. This is like a 6-sided dice. Okay. Well, we could roll a 1, 2, 3, 4, 5, or 6. That is 6 outcomes. Okay. Now, according to the fundamental counting principle, if we take the number of outcomes from M and N and multiply them together, that'll tell us the total number of outcomes. So if we take the 2 from here times the 6 from the number cube, That tells us there's 12 possible outcomes, which we could prove that this is true by creating a tree diagram, which you could, and you could test it. Okay. Okay, 2 more examples here. Find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. So first you pick a color. You have 3 color options. Then you have 2 styles. So 3 times 2. The outcomes from both of these. 3 times 2 equals 6. So there are 6 outcomes. Okay. Next one. The jean shop sells young men's jeans in different sizes, styles, and lengths as shown in the table. Find the number of jeans available. Then find the probability of selecting a size 32, 34 slim fit. So first let's find possible outcomes. Well, for waist size we have 1, 2, 3, 4, 5 outcomes. For length we have 1, 2, 3. And for style, again, we also have 3. So 5 times 3 is 15, times 3 is 45. So 45 possible types of jeans. Okay. Now we need to find the probability of picking 32 times 34 slim fit. Okay. Well, the waist size needs to be 32. The the length needs to be 34, and it needs to be slim cut. That's only 1 pair of jeans, so it would be 1 out of 45. Okay. So that is your video for sample space and fundamental counting principle. If you're stuck, go back and rewatch any part. Otherwise, look at your online textbook. Otherwise, take your 9.2/93 NICU.